Hello all, welcome to this video on microprocessors and microcontrollers. Today's topic of discussion is Intel 8051 microcontroller. We'll begin with why microcontrollers, then look into MCS 51 family of microcontrollers and then move on to the 8051 discussion. Let's begin. In the previous videos on microprocessor based systems, we have noted that a standalone microprocessor is not a self-sufficient system. It requires other components like memory and input-output devices to form a minimum workable system configuration. In addition to a microprocessor, the memory and I/O ports are the integral parts of a practical system. To have all these components in a discrete form and to assemble them onto a PCB is usually not an affordable solution due to the following reasons. The overall system cost of a microprocessor based system that is built on a CPU, memory, and other peripherals is high as compared to a microcontroller based system. A large sized PCB is required for assembling all these components, resulting in an enhanced cost of the system. Design of such PCBs will also require a lot of effort and time. Therefore, the overall product design requires more time. Due to the large size of the PCB and the discrete components used, the physical size of the product is big and therefore not handy. As discrete components are used, the system is not reliable and difficult to troubleshoot. Considering all these problems, Intel decided to integrate a microprocessor along with I/O ports and the minimum memory into a single package. Another frequently used peripheral, a programmable timer, was also integrated to make this device a self-sufficient one. This device, which contains a microprocessor and the above mentioned components, has been named a microcontroller. So, a microcontroller is a microprocessor with integrated peripherals. The introduction of microcontrollers drastically changed the microprocessor based system design concepts, especially in case of small dedicated systems. Design with microcontrollers have the following advantages. As the peripherals are integrated into a single chip, the overall system cost will be low. The size of the product is small as compared to the microprocessor based systems, therefore handy. The system design requires very little effort and is easy to troubleshoot and maintain. As the peripherals are integrated with a microprocessor, the system will be more reliable. Though a microcontroller may have on-chip RAM, ROM, and I/O ports, additional peripherals may be interfaced externally if required. Microcontrollers with on-chip ROM provide a software security feature which is not available with microprocessor-based systems using ROM or EEPROM. All these features are available in a 40-pin package as in an 8-bit processor. However, in case of larger system design, which requires more number of I/O ports and more memory capacity, the system designer may interface the external I/O ports and memory with the system. In such cases, microcontroller-based systems are not so attractive as they are in case of small dedicated systems. The figure on the right shows a typical microcontroller internal block diagram, which consists of a microprocessor, RAM or ROM memory, I/O ports, and peripherals such as a timer. As a microcontroller contains most of the components required to form a microprocessor system, it is sometimes called a single chip microcomputer. Since it also has the ability to easily implement simple control functions, it is most frequently called a microcontroller. Now let us look into Intel's family of 8-bit microcontrollers. Earlier versions of Intel's microcontrollers do not have an on-chip EEPROM. 8031 was one such microcontroller from Intel, followed by 8051 family. 8751 was the first microcontroller version with an on-chip EEPROM, followed by a number of 8751 versions with slight modifications. 8951 came with an electrically programmable and erasable version of 8051. The table on the right gives us a comparison between different versions of 8051. All these members of the 8051 family have identical instruction set and similar architecture, only with slight variations. The MCS 51 products are optimized for control applications. Byte processing and numerical operations on small data structures are facilitated by fast addressing modes for accessing the internal RAM. The instruction set provides a convenient menu of 8-bit arithmetic instructions, including multiply and divide. Extensive on-chip support is provided for 1-bit variables as a separate data type, allowing direct bit manipulation and testing in control and logic systems that require Boolean processing. Now we'll move on to MCS 51 family. This is the family of microcontroller ICs developed by Intel in 1980s. So MCS traditionally indicates the system or family of compatible Intel microcomputer components, including CPUs, memories, clock generators, I/O expanders, and so forth. The numerical suffix indicate microcomputer that serve as the cornerstone of the family. The generic MCS 51 IC is the 8051, the first device in the family that was offered commercially. John H. Wharton was behind its instruction set architecture. Originally, it was developed using an N-type metal oxide semiconductor NMOS technology, like its predecessor Intel MCS 48, but later versions like 80C51 use complementary metal oxide semiconductor CMOS technology. In 1996, they came up with an enhanced 8-bit MCS 151 and MCS 251 family of binary compatible microcontrollers. While Intel no longer manufacture them, enhanced binary compatible derivatives that are made by numerous vendors remain popular even today. Intel discontinued its MCS 51 product line in March 2007. Now let us look into some of the features of 8051. It consists of an 8-bit ALU, 8-bit accumulator, 8-bit data bus with two 16-bit address buses, a program counter, and data pointer. It has 4 KB of on-chip ROM and 128 bytes of on-chip RAM. It can access 2 into 2 raised to 16 memory locations, that is 64 KB each of ROM and external RAM. It has 4 8-bit bidirectional input-output ports which are bit addressable. It supports UART, that is Universal Asynchronous Receiver Transmitter Serial Port, and two 16-bit counters or timers. It comes with an on-chip oscillator, Boolean processor, and supports power down mode. A number of high-level programming language compilers are available for 8051. Several C compilers are also available, most of which allow the programmer to specify where each variable should be stored in its 6 types of memory and provide access to 8051 specific hardware features like multiple register banks and bit manipulation instructions. One of the commercially available C compiler is Small Device C Compiler SDCC, which is an open source C compiler. Other high-level languages providing compilers include Pascal, C++, Object Pascal, Basic, Modula 2, and Forth. Now let us look into some of the enhanced variants of 8051. We'll begin with 8031, which is a reduced version of the original 8051 that had no internal program memory, ROM. To use this chip, external ROM had to be added containing the program that the 8031 would fetch and execute. List of its manufacturers include Signetix, Intel, and AMD. Next is 8052, which is an enhanced version of the original 8051 that features 256 bytes of internal RAM instead of the 128 bytes, 8 KB of ROM instead of 4 KB, and a third 16-bit timer. Most modern 8051 compatible microcontrollers include these features. Next is 8751, which is an 8051 with 4K EEPROM instead of 4 KB ROM. They were identical except for the non-volatile memory type. It comes with a ceramic package with a clear quartz window over the top of the die, so UV light could be used to erase the EEPROM. Some of the MCS51 compatible processors include Atmel AT89C2051, Philips S87C654, and Infineon SAB C515. Some of the applications of 8051 include automobiles, medical equipments, defense systems, robotics, consumer appliances, industrial processing, aeronautics, and space. That's all for now. Thank you. Thank you for listening.